Hello friends, and welcome to a new session with edupediaworld.com, your favorite portal for online education. Continuing with regression analysis, this session we shall see the properties of regression coefficients. We'll deal with the basic properties of regression coefficient, the most important ones, and then we shall take up a problem for practice. So here we go. The first property of regression coefficient says that the coefficient of correlation Rxy is the geometric mean of the two regression coefficients b and d. And we have seen this previously. We have seen in the previous session, and in fact we have derived this relationship Rxy equals root under b multiplied by d. A point to note here is that all the three b, d and Rxy, that is the regression coefficients and the correlation coefficient, will have the same sign. Let's just understand this. Let's say we have the relationship is Rxy is the geometric mean of b and d, that is it's the square root of the product of b and d. In case if the value of b is negative, the value of d will also be negative, and that will lead to a negative correlation. Okay, therefore we will have a minus sign here outside. Of course, inside the root, both the negatives, the product of two negative numbers, will give you a positive number. In the same way, if b is positive, your d will also be positive and your correlation value will be positive. Therefore we will have a positive value here. The point to note is that all the three will have same sign. Okay, R, B and D will always have the same sign. Fine. And these properties will help us out when we solve a problem to verify whether the answers are correct or not. Alright, so now let's move on to the next one. The second property says that if one of the regression coefficients, say b or d, is greater than 1, then the other one, d or b, will be less than 1. Yeah, such that the value of the product of b multiplied by d will be between 0 to 1. Okay, so if we have, say, value of b greater than 1, then the value of d will be less than 1. Or if the value of d happens to be if the value of b happens to be less than 1, then the value of d will be greater than 1, such that when you find the product of these two, b multiplied by d, the value will always be between 0 to 1. Okay, let's move on. The next property says that the arithmetic mean of the numerical value of the regression coefficients b and d will be greater than or equal to the coefficient of correlation Rxy. Yeah, that is, if you find the average of b and d, say b plus d by 2, okay, this is the arithmetic mean, then this will always be greater than the value of Rxy. Okay, so your b plus d by 2 will always be greater than Rxy. Fine. So this is our first, second and the third properties. And the final one, it says that the regression coefficients b and d are independent of change of origin but not independent of change of scale. Well, we have seen these independence, that is the independent of change of origin and scale, for all the previous values also. So here again, now this will help us in deriving the shortcut formula as we have been doing previously. So let's see this. We have the regression coefficients are independent of change of origin but not change of scale. Okay, so change of origin, what we do, let's say we have the variable x and y. What we do is we find the deviation, we shift the origin, and let's assume we have u equals x minus an assumed mean, say a. When we do this, and v equals, say, y minus another value b. Okay, when we do this thing, our formula is unaffected. That is, if you recall, our basic formula for b is n times summation x y minus summation x times summation y divided by n times summation x square minus summation x the whole square, right? In the same way for d. Now in case if I do this shifting of origin, okay, this thing, then our formula, the form of the formula is unaffected, and now my b will be equal to n times summation u multiplied by v minus summation u summation v divided by n times summation u square minus summation u the whole square. Okay, but this is not true if we take if we shift both the origin as well as the scale. Okay, but it is not independent of change of scale. In change of scale, what we do, we divide the value by a certain number. So now this time, in case if we take x, we have x, and if we transform it into u by shifting the origin and then also taking a scale by dividing it by a factor, say h. In the same way, if we take if we have y and we do this transformation from y to v by y minus b divided by, say, another factor, say k. Now in this case our formula will change. The form of the formula will change. So let's see how it changes, and so here from x we have got u equals x minus a divided by h. I can write this as, let's find for x will be equal to a plus uh, right? And in the same way, when we have v equals y minus b by, say, k, we will have y equals b plus vk, right? In the same way, if suppose I have to find the mean of x bar, this will be equal to a plus u bar h, right? The mean of u multiplied by h, the form remains the same. In the same way, the mean of y will be equal to b plus v k. Okay, let me give them numbers for convenience, 1 and 2, or let me give these two as 1, 2, this as 3, and this as 4. And if you recall your basic formula, let's take the other form of the formula. We have b equals summation of xi minus x bar times yi minus y bar divided by summation of xi minus x bar square. I'm just doing it for b. The same process could be done even for say d. Now let's substitute these values from here to this one. What we will have is in place of xi minus x bar, we will have we have this xi as a plus uh, so you'll have summation a plus uh times x bar is a plus u dash h, so a minus, right, you have a minus here, a plus u dash h. right? This summation is for the whole thing. Or let's do that, you know, in part. Let's not put the summation for now. Let's just take this part, that is x minus x bar. Okay, x minus x bar is a plus u h minus a plus u dash h. Now a and a will cancel out each other. We will be left out with h common and then u minus u bar. Okay, so my x minus x bar is h times u minus u bar. In the same way, if we take y minus y bar, we will have in place of h, or let's do it, we will have b plus vh minus b plus v dash h, right? Again, these two b's will cancel out each other. We'll be left out with vh minus v dash h. And take h common, we'll have v minus v dash. Okay, so now when we put these two here in this formula, we will have summation of h times u minus u bar, h times u minus u bar, and okay, we'll have h times u minus u bar, and then we have k times v minus v bar. Now h and k being being constants can be taken outside the summation, and again for the denominator, again we have xi minus x bar, so we'll have the same thing. We'll have summation h square, okay, h square times u minus u bar. Of course, both these h and k can be taken out, h and k, so you'll have h k divided by h square times summation u minus u bar times v minus v bar divided by summation u minus u bar square, right? Now if you look at this, this is exactly in the form as this, right? You see, you compare this part and this part, they are one and the same. The difference is this part, this h multiplied by k by h square, this factor. Now here again we can cancel out these h, so we'll be left out with k by h times exactly the same as what we have here. So this could be written as, you know, we have worked this out, and we had got this n times summation u v minus summation u summation v divided by n times summation u square minus summation u the whole square, right? So we will have exactly what we have got here. So this will be your value for b. Okay, this is the shortcut formula to get the value of b, in case if we use the step deviation. Okay, that is when we do both change of origin and change of scale. Step deviation. And in case of what we'll have for d will be equal to h by k times the same thing, n times summation uv minus summation u summation v divided by n times is n and not h, n times summation v square minus summation v the whole square. Okay, so here we have k divided by h, and here we have h divided by k. And if you remember, we had taken h as the factor while transforming x. So h, which we have taken as factor while transforming x, is in the denominator in case of b, and k is in the numerator, and it's the reciprocal here in case of d. Okay, so this is the formula we have. Now, for the ease of solving problems, it will always be better if we don't use the step deviation method, rather just deviation method. Okay, so for ease of solving problems, I would suggest that you use deviation method and not the step deviation method. That is, you just change the origin. Okay, just change the origin. Or further, to make things easier, you can take both these h and k as equal. In case if they are equal, you know what will happen, these two will cancel out each other. Yeah, if k equals h, then of course we'll cancel these two out and we'll be left out with just this part. The same here also. So either you just use the deviation method and not the step deviation method, or you take both the values of h and k equal. Okay, so that'll make things easy for you, and it'll be really short and easy to solve a problem. Alright, so now let's take a problem for practice. Well, here we have the marks in two different subjects, say marks in economics and marks in statistics. So let's solve this question by the shortcut method, that is by changing the origin or scale, or whichever is convenient. So here we have taken this marks in economics as x and statistics as y. Let me transform these values, first x into u. So u we can take as x minus, let's take a number from here, and we see here that the numbers are not, they do not have a common factor, therefore we need not do it by step deviation method. We'll just change the origin. So let's take a middle value, let's say 31, and change this one. The same way v would be y minus a middle value, let's take say 41. Okay, so now putting that here, we will have x, which is 25, minus, let me put it directly, and in the same way y would be equal to this 43 minus 41. Okay, so here we have the formula ready. Let me drag it down to all the cells of these two columns. So here I have the values of u and v ready with me. Once I've got the value of u and v, we've seen that the form of the formula is the same, therefore we need the product of these two, u multiplied by v, that will be u multiplied by v, and then we need the square of u, right? So we'll have u raised to power 2, and also we need v raised to power 2. Okay, so let's do all of these one by one. Here u multiplied by v will be equal to this times the value here. U square will be equal to this raised to power 2, and v square will be this value raised to power 2. Okay, now we've got for all the three columns. Let me drag it down to the last value, and here we have. Okay, so now we have got all the required values, u, v, u square, v square, and u multiplied by v. Let me find the sum of all these. So the summation let me put the formula here itself, and then we'll drag it to all the values. Okay, so here we have the sum and then all the other cells. Yeah, so we've got the values of this u, v, u square, v square, and product of u, v. Fine. Now so let's find the, and of course to the formula of a and c remains the same. Okay, therefore we need to find the average values of both x and y, and if we use the deviation method to find the average, let me do that here. Average of x. Okay, let me do the average of x here. We can do it directly also, but since we have got the values here, let's take it this way. We have a as 31, right? A plus, that is a plus summation of u, which is 10, summation of u divided by the total number of data, and we see here we have 1 2 3 4 5 6 7 8 9 10, so that's also 10. Yeah, so average of x is 32. The same way, let's find the average of y. This will be b, which is 41, plus v, which is minus 30, divided by n, which is 10. Okay, so we have got the average of a and b as 32 and 38. Fine. Now we are ready to find the values of b and d, a, b, c and d. So let's do that here. Let's start with b. Usually we do that, right? So b equals, we have, what's the formula? If you recall, the formula is n times summation uv. So let me put that here. Let me open two parentheses. n is 10, right? 10 times summation u into v, the value here, right? And then minus, let's close one parenthesis, minus, we have summation of u multiplied by summation v, divided by, this is the numerator, and that will be divided by n times, n is 10, n times summation u square, that's here, minus summation u the whole square. Summation u is this value, raised to power 2. Okay, so when we do the calculation, we've got the value of b as minus 0.66429. okay, you can approximate it to minus 0.66. in the same way, let's do and find the value of d. Okay, so d equals, we have the same form of the formula. Our numerator is the same, what changes is the denominator. So let's just it's 10 times n times summation uv minus summation u minus summation u times summation v, divided by n times summation v square minus summation v the whole square, which is this value, raised to power 2. okay, so this is the value of d. Again, we see that both b and d are negative, and when we calculate r, I'm sure we'll get the value of r also as negative. Let's going to a. We have a equals, what's the formula of a? It's y bar, that is the average value of y, minus b times x bar. Okay, so a is y bar and our value of y bar is 38, so it's y bar minus b times the value of x bar. Okay, let's put this in parentheses just, yeah. So the value of a is 59.25. okay, now there could be, in case if you would have approximated this at minus 0.66, the round value, rounding it to 2 decimal places, then this will change slightly. Okay, so no worry about that. It's just an error which you get because of rounding. In case if you do not round, you'll get the whole value here like this. Okay, the values are even bigger. Yeah. Next, value of c. What's the value of c? The formula of c is x bar minus d times y bar. X bar, which is 32, minus d times y bar. Okay, so the value of C is 40.87. And finally, let's calculate the value of R. A value of R, which is square root of B multiplied by D. So R will be equal to square root of B multiplied by D. B multiplied by D. Okay, so the value of R is minus, of course we'll have to put a minus sign here, because within the square root, both the minus, the product of both the minus numbers will be plus. So if you go out here, but we know we have learned from the properties that if both B and D are negative, the value of R will also be negative. Therefore we'll have to put it as minus value of this. Okay, so we have square root of root under B multiplied by D equals minus 0.39, and that's our coefficient of correlation. Well, you can also check the value of R by the actual method of finding the coefficient of correlation, which we have learned previously. So let that be an exercise for you to do yourself. Let me write the equations here. The equations we will have two equations. Let me do that. Our equation of y first. Equation of y will be equal to a times a. What's the value of a? It's 59.25 a plus bx, but b was negative, so minus b. The value of b was 0.66 x. Okay, and this is of course the regression, let me put it as C, and similarly the regression value of the regression equation of x was what was the value of C is 40.87 and D is minus 2.3, so it's 40.87 again minus 0.23 y. So these are the equations we have, and this is the answer of the problem. Well, that's all we have in this session. We'll solve more problems and practice variety of problems in our next session. Keep watching Edupedia World videos. Thank you.